आज हम डिस्कस करेंगे इस थ्योरम के बारे में. Let S be a subset of R, then S is an open set if and only if S equals to int S. So first, assuming that S is an open set. Now if S equals to 5, which is an open set? In previous video I said that 5 is an open set. Then int S, the set of all interior points of S, is also 5 because S equals to 5 contains no points. So S has no interior points. So obviously int S, the set of all interior points of S, equals to 5. Because suppose S be a set, then S be a non-empty set. Then let C belongs to S. Then C is said to be an interior point if there exists some neighborhood of C such that neighborhood of C contained in S. But here S equals to 5 contains no point. So obviously int S is also 5. S has no interior points. Then therefore S equals to int S. Now if S not equals to 5, where S is an open set, because we assume that S is an open set. S is an open set. इसका अंदर 2 केस है, S equals to 5, S not equals to 5. We have to prove S equals to int S, where S is an open set. Now since S not equals to 5, let X belongs to S. And since let X belongs to S, since S is an open set, therefore X is an interior point of S. Because a set S is said to be an open set if and only if every point of S is an interior point of S. Now S is an open set, so every point of S is an interior point and X belongs to S, so X is an interior point of S. Therefore X belongs to int S, because X is an interior point of S, so X belongs to int S. So X belongs to S implies, so X belongs to S implies X belongs to int S. So S is a subset of int S. We name it 1. We have to prove S equals to int S. So let Y belongs to int S be a point. Then that is Y is an interior point of S. Now Y is an interior point of S, so obviously Y belongs to S. This implies Y belongs to S, because इसके अंदर पॉइंट कोई तो हम उसका इंटीरियर पॉइंट बोलते हैं जब सब कंडीशन सेटिस्फाई करते हैं, दैट सम नेबरहुड ऑफ उस पॉइंट कंटेन्ड इन S. दैट इज सपोज S बी ए सेट, लेट C बिलोंग्स टू S बी ए पॉइंट, देन C को हम इस सेट का इंटीरियर पॉइंट बोलेंगे जब सम नेबरहुड ऑफ C कंटेन्ड इन S. नाउ C, that is Y, is an interior point of S, so obviously Y belongs to S. Now therefore Y belongs to int S implies Y belongs to S, so int S subset of S. We name it 2. From 1 and 2, S equals to int S. Now we assume that, first assume that S is an open set. We show that S equals to int S. Now we conversely assuming that S equals to int S, and then we show that S is an open set. Conversely, let S be an non-empty set. S be a non-empty set. And S equals to int S. We have to show S is an open set. Now we choose here S as non-empty, because if we take S equals to 5, so nothing have to prove, because S equals to 5 is an open set. So we take S be a non-empty set. Now since S be a non-empty set, let X belongs to S be arbitrary point. Now since S equals to int S, so implies X belongs to int S, because S equals to int S, so obviously X belongs to S implies X belongs to int S, that is implies X is an interior point of S. But since X is an arbitrary point of S, since X is an arbitrary point of S, so every points of S is an interior point of S. Now X is an arbitrary point, so every point of S is an interior point of S. Therefore S is an open set, because a set S is said to be an open set if every point of S is an interior point of S. So hence S is an open set. Hence S is an open set, because every point of S is an interior point of S, so S is an open set. So we prove that if S be a subset of R, then S is an open set if and only if S equals to int S. If you like this video, please share and comment, and please subscribe.